The national map is a collection of mapping products and services produced by the USGS National Geospatial Program. The products and services are accessed via the Internet through service calls and graphical user interfaces. The National Geospatial Program has released a series of how-to videos for people who are working with the national map data and services. The videos show how to use services and interfaces to access data and tools for viewing, analyzing, and printing geospatial data. Lessons 1 and 2 serve as an introduction to the training materials, and the remaining how-to videos may be viewed as needed in any order, depending on the user. In this lesson, we will discuss each of the 8 base layers of the national map, or TNM. Understanding the content of each layer, where the data comes from, and how this information is managed is an important step in better utilizing the national map and its products and services. The composition of the national map is complex and cannot be fully described in one lesson. In this video, we hope to provide a general overview of the major features and attributes, authoritative sources, maintenance activities, and additional resources for more information for each of the 8 base layers. If you would like to jump to a specific part of this lesson, timecode links are available in the video description below. The national map is a collaborative effort between the USGS and other federal, state, and local partners to improve and deliver topographic information for the nation, and is a significant contribution to the National Spatial Data Infrastructure, or NSDI. The goal of the NSDI is to create and provide the geospatial knowledge required to understand, protect, and promote our national and global interests. The Federal Geographic Data Committee, or FGDC, is the U.S. interagency coordinating body for NSDI-related activities, and operates under the authority of the Geospatial Data Act of 2018 and Office of Management and Budget Circular, A16. The FGDC develops policies and partnerships to advance the development of the NSDI and promote federal and national geospatial initiatives. FGDC activities are administered through the FGDC Secretariat, hosted by the U.S. Geological Survey. For more information, please visit fgdc.gov. Over 170 geospatial datasets referred to as National Geospatial Data Assets, or NGDAs, make up the NSDI and are categorized into 18 NGDA themes. The full list may be accessed at ngda-portfolio-geoplatform.hub.arcgis.com. Throughout this lesson, we will identify which components of the national map are FGDC-designated NGDAs. The 8 base layers of the national map are elevation, hydrography, geographic names, land cover, boundaries, transportation, structures, and orthoimagery. The National Map Initiative aims to provide accurate, timely, and consistent data within each of these 8 layers for the conterminous United States, Alaska, Hawaii, and the U.S. territories. Let us begin discussing these layers in detail, beginning with elevation. Elevation. The elevation layer of the national map comes primarily from the 3D elevation program, also known as 3DEP. USGS manages the 3D elevation program on behalf of the user community and the public to provide nationwide high-quality elevation data to support a broad range of applications. 3DEP is based on the results of the 2012 National Enhanced Elevation Assessment, NEA. The study identified more than 600 requirements for 3-dimensional elevation data to address mission-critical information requirements of 34 federal agencies, all 50 states, and a sample of private sector companies and tribal and local governments. A fully funded and implemented 3DEP will return more than $690 million annually in new benefits and has the potential to generate $13 billion per year in new benefits throughout applications that span the economy. This would result in a 5-to-1 return on investment, informing critical decisions that are made across the nation every day that depend on elevation data, ranging from immediate safety of life, property, and environment to long-term planning for infrastructure projects. The goal of 3DEP is to complete acquisition of nationwide LiDAR, IFSAR in Alaska, to provide the first ever national baseline of consistent, high-resolution topographic elevation data, both bare Earth and 3D point clouds. 3DEP products are sourced from high-quality light detection and ranging, or LiDAR data, for the conterminous United States, Hawaii, and its U.S. territories, and interferometric synthetic aperture radar, or IFSAR data for Alaska, where remoteness and persistent cloud cover prevents statewide coverage of LiDAR data. This effort requires broad support from a large partnership community committed to the achievement of national 3D elevation data coverage. The initiative is being led by the USGS and includes many partners, federal agencies and state, tribal, and local governments, who are working together to build a national collection of 3D elevation data. If you are a regular user of elevation data, you will be well served to monitor the progress of 3DEP data acquisition using the link shown here, usgs.gov/3DEP. 3DEP LiDAR data are collected from aircraft using sensors that detect reflections of a pulsed laser beam. The reflections are recorded as billions of individual points, collectively called a point cloud, that represents 3D positions of objects on the surface of the Earth, including buildings, vegetation, the ground, and other features. Various surface models can be created from the point cloud data, such as digital surface models, DSMs, a first return surface, or a DEM, a bare Earth surface. The shaded relief and contours of the national map and U.S. topo products are derived from 3DEP's 1-meter DEMs, where it is available. In addition, the intensity of the reflected light is measured and stored as an attribute of the point, allowing a type of image that can be created from the LiDAR data. The LiDAR point cloud data can be further processed to model the shape and volume of buildings, the size of trees or density of vegetation, the land cover categories, line of sight, and many other physical phenomena to support a wide variety of applications. The table shows the standard products that are currently part of 3DEP. The LiDAR point cloud, the 1/3 arc-second DEM, the 1-meter DEM, and the 5-meter Alaska DEM are FGDC designated NGDAs under the elevation theme, which is co-led by USGS and NOAA. The 1/9 arc-second layer is now considered a legacy product, and no new projects will be added to it. Instead, all new high-resolution bare Earth data are produced at a 1-meter resolution. In addition to the standard data products listed in the previous slide, users have access to the classified point cloud, the IFSAR digital surface model, and the ortho-rectified IFSAR intensity image. To use the data properly, it is important to understand the quality of the LiDAR and IFSAR data that is being collected. The table shows the source and vertical accuracies for each quality level as well as the resulting DEM products. USGS 3DEP requires quality level 2 or better LiDAR. For example, QL2 LiDAR's vertical accuracy is 10 centimeters, which is suitable for the production of 1-meter DEMs. The USGS LiDAR base specification sets the benchmark for quality metrics. It sets the methods through which the data are collected, processed, and provisioned to adhere to this contemporaneous specification. At the minimum, any emerging technology would need to meet these benchmarks. The specification is continuously being updated to reflect changes in technology. The latest version of the report can be accessed by following the link, usgs.gov/3DEP/LiDAR-spec. To learn more about partnering with 3DEP, follow the link to usgs.gov/3DEP/collaborate. If you are interested in learning more about elevation, LiDAR, and working with the data, we encourage you to see the Lesson 10 series of these training videos at usgs.gov/NGP videos. Hydrography. The hydrography layer of the national map includes the National Hydrography Dataset, referred to as NHD, as well as the Watershed Boundary Dataset, known as WBD. The NHD and WBD are also NGDA datasets under the Water Inland theme, co-led by the USGS. NHD and WBD, along with the 3D elevation program data, are used to produce the NHD Plus high resolution. These are the most up-to-date and comprehensive geospatial datasets depicting the nation's hydrography. These datasets have been created and maintained in cooperation with a network of data stewards that includes agreements with 41 states and the District of Columbia. These national hydrography datasets support 420 mission-critical applications with federal agencies, states, tribal governments, and national associations. Now let's take a brief overview with each of these datasets. The National Hydrography Dataset, or NHD, is a drainage network of springs, streams, lakes, canals, along with other hydrographic features. Information attached to these features indicate flow direction and assist with network navigation. Reach codes and measures provide an addressing system similar to street addresses. The features in NHD form the surface water layer of the national map. Many of these features are seen on USGS topographic maps, and much of the original NHD can trace its origins to topographic maps. Now NHD is continuously updated at 1 to 24,000 or larger scale. NHD and the Watershed Boundary Dataset, WBD, are companion datasets. The WBD represents the drainage area in the United States. These drainage areas are known as hydrologic units, HU, and their boundaries are determined by hydrographic, topographic, and other relevant landscape characteristics. The hydrologic units are arranged in a nested hierarchical system with each level assigned a progressive two-digit hydrologic unit code, or HUC. If we think of the NHD as the stream's street address, the WBD can be thought of as the zip codes for the hydrologic addressing system. NHD Plus High Resolution integrates NHD, WBD, and 3-depth elevation program digital elevation models, or DEMs, to create a hydrography framework for the nation. This allows for a better understanding of rivers and their drainage areas called catchments. NHD Plus High Resolution has an elevation-based catchment area for each flow line. NHD Plus High Resolution also indicates value-added attributes, or VAAs, that enable NHD Plus High Resolution to better model water flow for stream network navigation, analysis, and display. NHD Plus High Resolution also includes flow direction, flow accumulation, elevation, hydro-enforced elevation, and other raster datasets used in or created during the NHD Plus High Resolution production process. Applications of this dataset range from environmental modeling to bridge and culvert infrastructure engineering. There are several tools to assist with the management and analysis of the NHD. For example, the Markup application is a web-based mapping tool that enables users to suggest edits to the NHD, WBD, and NHD Plus High Resolution that will be reviewed by the USGS and stewards, and if approved, entered into the NHD. For more information on these tools, follow the link to the usgs.gov/NHD/tools. This was just a very brief look at NHD, WBD, and NHD Plus High Resolution, and you will learn more in the Lesson 15 TNM training series. In addition to these training videos, there is extensive documentation and user resources such as tutorials, standards, and feature details that can be found on the NHD website at usgs.gov/NHD. The USGS also has a National Hydrography Datasets playlist on the USGS YouTube channel. This provides a dedicated space for videos and presentation recordings on a variety of topics related to the NHD, WBD, and NHD Plus High Resolution. Consider subscribing to the channel so you are notified of new videos. Geographic Names. The Geographic Names Information System, or GNIS, is the federal and national standard for geographic nomenclature, as well as the basis for the geographic names component of the national map. GNIS is a designated NGDA dataset under the Cultural Resources theme, and the USGS is its dataset manager. This dataset was first developed in 1974 in support of the U.S. Board on Geographic Names, commonly referred to as the BGN. The Domestic Names Committee on the board is comprised of representatives of federal agencies concerned with geographic information, population, ecology, and management of public lands, and maintains working relationships with state, federal, local, and tribal authorities to coordinate the standardization of geographic names across all levels of government. The BGN was created in 1890 and established in its present form by public law in 1947, following the surge of exploration, mining, and settlement of Western territories after the American Civil War, when geographic name inconsistencies and contradictions became a serious problem to surveyors, map makers, and scientists. Alongside the Secretary of the Interior, the BGN promulgates official geographic feature names with locative attributes as well as principles, policies, and procedures governing the use of domestic names, foreign names, Antarctic names, and undersea feature names. Only official geographic names and locations, which are those approved by the BGN or by BGN policy, should be used on federal products. More information on the U.S. Board of Geographic Names and Domestic Name Committee can be found at usgs.gov/US Board on Geographic Names /domestic names. Names data for each state or territory was compiled from topographic maps published by USGS, maps from the USDA's Forest Service, charts of NOAA's National Ocean Service, and a variety of other authoritative federal, state, and local materials, as well as historical documents. Today, GNIS contains records on more than 1 million geographic names for features such as populated places, streams, valleys, ridges, and many other feature types excluding roads and highways, for the 50 states, the District of Columbia, the territories, and outlying areas of the United States. Each feature in GNIS has at minimum a name, a location, and a feature ID, which is a unique permanent feature identifier for accessing, integrating, or reconciling feature data with other datasets such as the National Hydrography dataset. The query interface seen here can be accessed by clicking Search Domestic Names at the website mentioned previously. GNIS data is also available as web map and feature services as well as via file download services. Land cover. Land cover on the national map is from the National Land Cover Database, or NLCD. The NLCD is the definitive Landsat-based 30-meter resolution land cover database for the nation, and is also the source from which the woodland tint layer on U.S. topo maps and the national map is derived. The NLCD is generated through the efforts of many federal agencies as a part of the Multi-Resolution Land Characteristics Consortium. Several NLCD products are National Geospatial Data Assets under the NGDA land cover theme. The NLCD provides spatial reference and descriptive data for characteristics of the land surface thematic class, such as urban, agriculture, and forest, as well as percent impervious surface and percent tree canopy cover. NLCD supports a wide variety of federal, state, local, and non-governmental applications by providing data and products that can improve decision-making processes. More information about land cover can be found by visiting the link mrlc.gov. The classification system used by NLCD is based on a modified Anderson Level 2 classification system. More information on this classification scheme can be found by visiting the link shown here. NLCD 2016 and 2019 are based on an updated approach to land cover mapping, including the comprehensive methods, models, and procedures that are shown here. NLCD 2016 and 2019 now offer land cover for 7 years and impervious surface for 4 years. These products update all previously released versions of land cover and impervious surface products for CONUS, and are not directly comparable to previous products. All NLCD data products are available for download at no charge to the public. A product incorporated for the NLCD 2016 and 2019 is the Land Cover Change Index. This index, displayed, provides a simple and comprehensive way to visualize change from all 7 dates of land cover in a single layer. NLCD 2016 and 2019 also offers an impervious surface descriptor product. This product identifies types of roads, core urban areas, and energy production sites for each impervious pixel to allow deeper analysis of developed features. Large, complex national databases such as the NLCD are most useful in support of regional and national analyses. However, NLCD is used for a vast array of topical applications, some of which are shown here. NLCD strives to conduct formal accuracy assessments to provide user feedback on product accuracy. Users need to know that product accuracy can vary by regional geography and specific class type. More detailed information can be found on the MRLC website, mrlc.gov. Boundaries. Boundary data represents major civil areas for the nation and are useful in understanding the extent of jurisdictional and administrative units for a wide range of applications, including managing resources, responding to natural disasters, and engaging in recreational activities. The boundaries layer for the national map is sourced primarily from federal partners, including the U.S. Census Bureau, the U.S. Forest Service, the National Park Service, the U.S. Fish and Wildlife Service, and the Bureau of Land Management. Additionally, the international boundaries between the United States and Canada and the United States and Mexico are acquired from the International Boundary Commission and the International Water and Boundary Commission, respectively. Also included in this national boundary dataset are state and county boundaries, incorporated places such as cities and towns, as well as American Indian, Alaskan Native, Hawaiian, or AIANHH areas, and federal lands, among many other governmental and administrative boundaries. The national map adopts federal partner boundary data with minimal editing or review by USGS. This aligns with the intent of Part 5 of the Federal Geographic Data Committee's Geographic Information Framework Content Standard. Part 5, Governmental Unit and Other Geographic Area Boundaries establish the requirements for collection and interchange of governmental units and other geographic area boundary data and facilitates the maintenance and use of that information. By adhering to Part 5, a common baseline for the semantic content of the dataset, such as terminology, definitions, encoding schema, and the data required to describe a boundary is established. Working with authoritative data partners discourages the collection of duplicate data, decreases costs, and enables long-term improvement of geospatial boundary data within the community. Part 5 of the Geographic Information Framework Content Standard is available in its entirety on the FGDC website. The USGS plans to shift to using the Protected Areas Database of the United States, or PAD-US, as the exclusive source of authoritative land management agency boundaries, including all available federal sources for the national map. PAD-US is the nation's official inventory of public open space and private protected areas, and is comprised of federal, state, local, and nonprofit data. Full transition to PAD-US sources will take several years, but the integration of land management agency boundaries will begin at the federal level, then move on to the adoption of state data, and conclude with the incorporation of local jurisdictional boundaries. If you would like to learn more, please visit protectedlands.net or go to the PAD-US Viewer application at maps.usgs.gov/PAD-US to explore the dataset. Transportation. The National Map Transportation layer comes from the USGS's National Transportation Dataset, a seamless integrated dataset containing features associated with the transportation of people and commerce, such as roads, railroads, trails, and airports. It offers nationwide coverage with consistent feature symbology, including the appearance of different road classifications and route symbols. Roads are primarily based on Tiger Line data provided by the U.S. Census Bureau and supplemented with U.S. Forest Service and National Park Service road data. All railroads are provided by the Federal Railroad Administration. Airport points and runway polygons are updated using data provided by the Federal Aviation Administration. Trails come from a variety of sources, including the U.S. Forest Service, the National Park Service, the U.S. Fish and Wildlife Service, as well as the National Digital Trails Project, a Department of Interior initiative to expand recreational opportunities on the nation's public lands. Ferry routes, tunnels, and other transportation features can also be found in this dataset. The content of the National Transportation Dataset adheres to a unique and complex schema. This allows the heterogeneous source datasets which make up the transportation layer to be represented in a consistent and comprehensible manner, and enables the visualization and analysis of these data for public safety, urban planning, emergency management, environmental assessment, and many other applications. Structures. The USGS maintains the National Structures Dataset, from which the structures layer of the national map is obtained. This National Structures Dataset is also an FGDC designated National Geospatial Data Asset under the Real Property theme. The types of structures in this database were largely determined by the needs of our cartographic products and services, various focus areas including emergency services, natural resources, and input from federal partners. Data currently being collected includes selected man-made structures such as schools, emergency response, law enforcement facilities, post offices, hospitals, and government facilities. Each structure is categorized into one of 6 subtypes. Each data point also contains key attributes such as structure name, building location, and address. Many of these attributes are specific to the building type. The structures data model linked here provides the entire list of attributes. Ultimately, this attribute information allows for uniform symbology of U.S. topomaps. Here are some examples of the structures and their symbology that show up in U.S. topomaps. A subset of structures shown here have been identified to be of major importance to the production of U.S. topomaps. The USGS is continuously working to identify authoritative data sources to expand the National Structures Dataset. Maintenance of the structures database is continual and varies according to agreements with partners and data availability. Certain features are revised based on updates from a variety of partner data. The majority of recent updates have been made possible through the efforts of the National Map Corps, an online crowdsourced mapping project. Volunteers of the National Map Corps are successfully editing structures in all 50 states, Puerto Rico, and the U.S. Virgin Islands. Through this program, they can improve structure data by adding new features, removing obsolete points, and correcting existing data using the web-based mapping tool. Both newly collected and modified point features become part of the USGS National Structures Dataset, then eventually show up on the national map and ultimately U.S. topomaps. If you are interested in becoming a member of the National Map Corps, please go to edits.nationalmap.gov/TNM Corps. More information about structures can be found here. The National Structures Dataset point data is supplemented by the National Map Structures tint layer. This dataset provided by Oak Ridge National Labs and the Federal Emergency Management Agency represents man-made structures using broad area tints rather than defining the exact shape of the individual buildings. The structure's tint is currently visible as a light purple shapes on the USGS Topo Base map. In future, it will be downloadable through the National Map Download Client, available as its own map service, and included as a data layer on US Topo maps. Orthoimagery. The final layer of the national map we will discuss is orthoimagery. High-resolution, ortho-rectified digital aerial photographs and satellite images make up the image component of the national map. The process of orthorectification removes feature displacement and scale variations caused by terrain relief and sensor geometry. The result is a combination of the image characteristics of an aerial photograph or satellite image and the geometric qualities of a planimetric map. These attributes allow users to measure distance, calculate area or direction, determine shapes of features, take accurate coordinates, identify land cover and use, perform change detection, and update maps. Orthoimagery is easily mosaic to create images of larger areas, so it often serves as a seamless base map layer to which many other layers are registered. Orthoimagery also supports various geographic information analyses and mapping applications, such as the creation and maintenance of land boundaries, natural resources inventory and assessment, infrastructure development, emergency planning, and much more. Orthoimagery of the continental United States comes from the U.S. Department of Agriculture's National Agriculture Imagery Program, or NAIP, and has a 0.6 meter resolution. NAIP imagery is refreshed at least every 3 years, with 1/3 or more of the continental U.S. flown each year. Orthoimagery for Alaska, Hawaii, as well as Puerto Rico and the U.S. Virgin Islands is provided through partnerships between the USGS, other government agencies, and the private sector. Resolution for these areas is currently 10 meters or better and is likely to improve in the coming years. However, the data may be subject to longer refresh cycles. The national map provides the most recent compressed NAIP orthoimagery via web services or as downloadable 3.75-minute longitude by 3.75-minute latitude tiles. Historical NAIP archives, as well as many other remotely sensed datasets, can be accessed through the USGS Earth Resources Observation and Science, or EROS, Earth Explorer Data Portal, at earthexplorer.usgs.gov. For more information on Earth Explorer, please see Lesson 7 of this training series. Conclusion. In closing, let us briefly discuss the significance of the national map. The national map meets federal mapping requirements, serves the needs of both digital and paper map users, helps ensure standards for digital and paper maps, and reduces redundancy in federal mapping efforts. There is considerable effort within the USGS and beyond to aggregate and maintain the data layers of the national map so that it may continue to serve as the digital geospatial foundation for the nation. Furthermore, the national map aims to present the most reliable, accurate, timely, and nationally complete data. Thus, the source of a given layer may vary in the future from what is presented in this lesson. To find the most current data sources, please visit sciencebase.gov and enter keywords National Map into the search engine. A consolidated repository of the national map specifications and data model posters may be found at specx.nationalmap.gov. As mentioned previously, all layers of the national map can be viewed at the National Map Viewer at apps.nationalmap.gov/viewer. Additionally, most datasets are available for download through the TNM download application at apps.nationalmap.gov/downloader, or as web services at apps.nationalmap.gov/services. Lastly, TNM data are also hosted for direct download at usgs.gov/nationalmap/cloud-browse. In this lesson, you learned about the 8 layers of the national map: elevation, hydrography, geographic names, land cover, boundaries, transportation, structures, and orthoimagery, as well as each layer's major features and attributes, authoritative sources, and maintenance activities. You have reached the conclusion of Lesson 2. If you would like to return to specific sections of this lesson, timecode links associated with each layer of the national map are available in the video description below. Thank you for your time and attention.